Hey guys, how are you doing? How are you doing?
I'm good.
Good. You're back at school, Paris? Okay, that's nice. Lainey, how are you doing?
I'm good.
Surviving? Che, is that Michigan? Is that Michigan behind you?
Yeah, it is. It's like
Okay.
30 degrees and snowing.
Is it really? It's snowing?
Yeah, it was a cold morning this morning.
Oh, ouch. Ouch. Did you get your run in?
Yeah, running and workout, so it's good.
Ah, horrible, horrible. Lindsay, how are you doing?
I'm good.
That's good. Colin, how about you? Colin, where are you?
Um,
Good, okay. Mason, how are you doing?
Doing fine.
That can't possibly be your dorm. You'd never have that sign behind you. That's gotta be home. That's gotta be home.
Well, I did have the sign behind me the month we were all back at home.
Okay, okay, yeah.
So,
But that's not one of your pieces in your dorm.
no,
Okay.
the
That's,
dorm buildings are not orange on the inside.
oh, okay, okay. See what time Verizon has here. 59. Miles, how are you doing?
I'm good. How are you?
Surviving. Did you guys have a good break?
Yes, sir.
That's hopefully everybody stayed COVID free. Hopefully, we'll see. Alex, how are you?
I'm doing great, Professor. How are you doing?
Doing good. Internet, huh? Starbucks internet, good. Shows dedication.
Yeah, I'm here with my best friend. We're doing our classes outside.
Okay, let's stand up. We've got so much to do. Stretch, you know you need this. Okay, let's sit back down. I decided over break that your final in-class quest before our final quest, okay, is going to be this Friday. It's going to be over our chapter 5, which was the integration, the derivatives, and talking about the exponential and logarithm functions. All that stuff that we've gone over related to exponential and logarithms. So everything that we covered in chapter 5. So your notes and your homeworks that I assigned. There's not a ton of material there, but there's still plenty for a good quest. So when's your final in-class quest? Friday. Okay. Our final quest will be during our final exam time, which sucks because it's Friday, December 18th. Who would want an earlier slot than Friday, December 18th?
I think I'm working that day.
If there's enough people that want another slot, I think I may offer two slots. So I'll talk more about that next week. Our final time we meet is next Wednesday. There is no class the next Friday. So the final time that we meet is next Wednesday. For those who weren't with us in our last in-person class and that had already left for Thanksgiving, we started talking about what topic? Integration, the dreaded definite integral, okay? And so that's where we want to start. Back up, okay? You have a quest on Friday over exponentials and logarithms. And today we're going to start the definite integral. Now I know it's hard to read, but most of the time you can hear me. Can you hear me okay? Can you guys hear me okay? Hearing's not the issue. It's always seeing with this. So we've got this symbol that it's just a number. It's the definite integral. It's like an infinite sum. That's why they have this elongated s. The integral from a to b of f of x dx. Read what I just read.
The integral from a to b of f of x.
Okay, calculus is about, what have I taught you? Calculus is about,
Limits, derivatives, and integrals.
oh my. it's not shocking that the integral, the last major topic, is defined in terms of a limit. It's just a more complicated limit than what we've dealt with. It's not the limit as x approaches c, but it's the limit as n approaches infinity. We're not going to unpack that much. It's defined in terms of a limit. The thing is, the limit's defined in terms of one of the things you hated the most in high school and feared, which was the summation sign, the sum sign. The sum is going from 1, k equals 1, to n. There's n terms in the sum. The problem with the sum is that k goes from 1 to n, but the k is inside the function. It's x sub k. Say what I just said.
X of k.
It's x sub k. It's the sum of k equals 1 to n of f of x sub k times delta x. So it looks hard, but guys, it's not really all that hard once you start unpacking it. It's just a lot of notation. It looks hard, but it's not that hard. It's the sum of k equals 1 to n of f of x sub k times delta x. Now we've got to explain to our reader who is the delta x and who are these x sub k's. Most of the times kids get functions. They understand the a and the b, but they struggle with the delta x and the x sub k's. So what I want you to do is I want you to draw yourself an xy axis, much like what I did here, and draw yourself a function, something that passes the vertical line test. Give yourself an f. So you got your x-axis and your y-axis, and draw yourself an f. The more I make you do, the less reading you have to do. Now what we notice is that these x sub k's are equal to a plus k times delta x as k goes from 0 to n. So the first thing I notice is that x sub k has an a in it plus k times delta x's. And since these are going into the function, then this a has to be somewhere on the x-axis. It's a domain value. So just mark yourself an a, and that's what I did there. Mark yourself an a. Well, delta x is equal to b minus a over n, then b's got to be a domain value. It's with the a. So give yourself a b that's bigger than a. Now what we're going to do is kind of like what we did in class last time, for those who weren't there. We're going to unpack this. We're going to unpack this for n equals 4. If we can't understand it for 4, are we screwed anyhow? If you can't understand it for n equals 4, are you going to understand it as n goes to infinity? And the answer is no. So let's unpack it for n equals 4. So I choose n to be equal to 4. Now I look over here, then delta x would be equal to, can you read? Delta x would be equal to,
B minus A over N.
and what did we just pick n to be? What did we just pick n to be? 4. So delta x would be equal to b minus a over 4. So we're taking the distance between a and b. So I can't do this with one hand, but you guys, down on your paper, put over b and a. Hold up that distance, and I'll do the same thing here with mine. Here's my distance. This is my b, the distance between b and a. And I'm going to chop it into how many pieces? I'm going to chop it into how many pieces? 4. So let's do that. Let's chop our domain, and you guys do the same thing. Chop this into 4 equal pieces. And so you guys do the same. Chop the distance between a and b, that interval between a and b, into 4 equal pieces. And I'll do the same thing. Now we know the length of each one of these chunks of the domain is delta x. So mark it as delta x. Mark each of those chunks as delta x. you know, I'll do the same thing. This is a delta x, that chunk's delta x long. I've got 4 pieces that are all linked delta x. Okay, we've got our function, Here's the function. We've got an A and a B. We've got an A and a B. Do you guys agree or disagree? You agree or disagree? Mike, are you there? Mike, are you there? Mike.
Yeah, I'm there.
Okay, making sure. Christian, are you with me? I love to teach faces, not names. Brad, are you there? Brad?
Yeah.
Okay.
Yeah.
Christian, are you there? Christian? Are you?
Texted in the chat.
Okay, good. Just making sure. My job is to what? Teach, yeah. So I've got to keep you on the field. Does this make sense? If I'm going to teach you, I need you on the field. Zach, does this make sense?
Yes.
Okay, good. So how many people understand there's an F? How many people understand there's an F? And how many people understand there's an A and a B? How many people understand the A and the B? We're unpacking this only for n equals what right now? This is going to know who's actually been awake. For n equals what right now? 4. We took our delta x, b minus a over 4, which chopped these into 4 equal pieces. Now we're for the part that kids understand the least. I don't know why they think this is so hard, because it's not really that hard. That line right there just screws kids up. And I'm going to show you it's not that bad. We've got our x sub k, which is equal to a. You guys read to me. X sub k is equal to
A
plus
K delta x.
4
K equals 0.
through n.
Not x.
So we would have x is equal to a plus k delta x as k goes from 0, 1, all the way up to n. But who do we pick our n to be? What number did we pick our n to be? What's our last one? 4.
4.
So let's start when k is 0. So when I put a 0 in for k, I get an a plus 0 times delta x. Well, what's 0 times delta x? 0. So x sub 0 would be equal to a plus 0 times delta x, which would just be a, which would just be the point A. So under here, write that down in your drawing as x0. A is the same thing as x0. So mark this as x0. Now let's look at the next value of k. K is going from 0 to 4, so what's the next number? It's not that hard. 1. So we put in an x1, and this is equal to a plus 1 delta x, which is just moving over a delta x. Now look at your drawing. Look down here in the domain. If you are at a and you add a delta x, where are you at? If you're at here at a and you add a delta x, where are you?
A plus delta x.
Yeah, you just go over here, and so this would be the point x1. Does this make sense? Is this making sense? Are you guys following me? So now let's look at the next one. x2 would be equal to a plus
2 delta x.
2 delta x. So we start at a, and we jump up 2 delta x's. So this point would be x2. And you guys are beginning to see the pattern. You're beginning to see the pattern here. This point would be
x3.
x3. And this last point would be x sub 4. So this is where we would keep doing this. And that gets us all the way across to B. So how many people are following so far? How many people are following so far? Now let's look at this. Because that's the last part we really need to unpack. It's the summation. Now who did we pick n to be? Who did we pick n to be? 4. So it's the sum of k equals 1 to 4 of f of x sub k times delta x. Now what does this symbol mean for a student to do in Algebra 2? What did you learn that symbol meant to do? What does this symbol, it's not a fraternity symbol, it's not a sorority symbol. What does that symbol mean to do in math?
Sum.
Sum. What does sum mean? If some kid doesn't know what the word sum means, what does sum mean?
Add.
Add. Wherever we see the k, we start at 1, we end at, that was a trick move. We start at 1, we end at 4, and we go through all the numbers in between, all the natural numbers. This is the only place where k is. It's a subscript, x sub k. So if I'm unpacking it, the first term would be, no matter what I said, nobody was going to listen. So let's see, what can I do? I'm not going to do Mickey, I don't want to hurt your ears. I'll do German. I'm going to do my German. My German. Now listen to me! The first term is when k is equal to 1. So when I see the k up with the 1, it broke my chuck. You will die. F of x sub 1 times delta x. I am done. What's the next value of k?
2.
You are not listening. Sum plus f of x sub 2 times delta x. What's the next value of k?
3.
You do not fear me because you are in degree. What's the final value of k? What's the final value of k?
4.
I cannot keep doing this. And so then we've unpacked it. Now this is just for n equals 4. Now let's look at this. We've got f of x1 times, you help me out. We have f of x1 times, you help me out. F of x1 times,
Delta x.
do we have delta x's in the drawing? Delta x's in the drawing? Are there delta x's in the game?
Yes.
What we don't have right now is the f of x1s, the f of x2s, the f of x3s, and the f of x4s. So I come over here. Here's x1. You guys shook your head. Yes, doctor, when I understand that. Here's f. How do I find f of x1? I've taught you this. How do I find f of x1 in this game? What do we do? You go straight up, and then you do what?
Go.
Shoot over. So this is f of x1. How many people are with me? How many people are still in the game? Now what I notice is the distance between here and here is f of x1. The distance between here and here is f of x1. Is that the same distance as between there and there? Because we went straight up and we went straight up and we went straight left. Is this distance the same as that distance? Now look here. Delta x is that distance. These are at right angles to each other. This is straight up, this is straight over. So if I think about this, this has the same distance as f of x1. This is delta x. It's like length times width. What does that give you? Length times width. What does that give you?
Area of a rectangle.
Area of a rectangle. Now what's the rectangle that's the area of? Look at that drawing and try your best to draw the rectangle That's the area of, that f of x1 times delta x. And this is good where I can see your faces, I can see people are still drawing. Well, this is like the length, this is like the width. So it'd be like the area of that rectangle right there. This f of x sub 1 times delta x is the area of that rectangle. Does this make sense to you guys? Does this make sense to you guys? Okay, we're done. We're not done. Look, there's three other terms. Let's look at this one. F of x sub 2 times delta x. Well, that would also represent the area of a rectangle. Do you think you could draw that rectangle? Try to do your best to draw the 3 remaining rectangles. I'll fix whatever you mess up. Try to do your best to draw the 3 remaining rectangles that are in that sum. Okay, I'm going to do the same. Here's x2. Here's x2. To find f of x2, I go straight. Find f of x2, I go straight up. Hit the graph. Oh, that wasn't real straight. I have not been drinking. I go straight up. I go straight over. So this would be like f of x2. This distance, which is the same as this distance. And so the area of this rectangle, f of x2 times delta x, that's this second term in the sum. The third term, I go up, shoot over, shoot up, shoot over. So this last one would be the area of f of x. The last one would have the area f of x. Help me out. The last one have the area. I'll keep yelling.
4.
F of x 4. I've learned from my daughters. Annoy until they answer. Annoy until they answer. F of x 4 times. How many people notice like sibling rivalries don't end when people grow up? How many people have noticed that? Like with their parents. Have you seen that with the parents? I mean, my brothers and I'm almost 60 years old. If we're together for more than 4 days, a piece of furniture is going to get broken. Because it's going to start like, I can take you now. You're 60. And I'm like, you're not going to take me. You could never take me. And before you know it, some piece of mom's furniture is broken in the house and we're buying her a new piece of furniture. Maybe mom plans it this way. Maybe she even wants new furniture. Not quite sure how it works. There's something about Thanksgiving. I mean, I don't know if you had a big Thanksgiving. You probably shouldn't have. But if you did, that is a really interesting meal. At my table, there's these sound effects of people who've eaten way too much. And you hear these like, Paul, pass me the mashed potatoes. I'm like, Uncle Harvey, you don't need anything else. Have you been listening to yourself? Last thing you need to be doing is putting anything into your body other than, and you hear somebody else across it. It's just like, oh my gosh, I don't think I can eat. I'm actually getting nauseous right now. Okay, well, enough of this. How many people are understanding me so far as this n equals 4? Now, what do we do with these areas? What do we do with these areas, guys? What are we doing with them?
Adding them.
Adding them together. And you're like, well, Dr. Warren, what does this approximate? Well, it approximates, in some ways, the area under the function down to the x-axis. it kind of approximates the area like that. Now here's the thing, before Newton, you look at a shape like that, how many people recognize that this shape is not a rectangle? How many people say, that is not a rectangle? If that's a rectangle to you, then you've got bigger issues. You've got bigger issues. How many people recognize it ain't a triangle? How many people recognize it ain't a triangle? How many people recognize it's not a trapezoid? You're like, I don't even know what that is anymore. How many people recognize it's not a trapezoid? How many people know it's not a circle? How many people recognize that ain't a circle? Now here's the thing. That was all they knew how to get area of until 1700. That was pretty much it. It's a miracle that they got a circle. Triangles, trapezoids, rectangles, circles, that was it. And Newton comes along with his fundamental theorem of calculus and opens up a whole new world. We're heading to the fundamental theorem of calculus. I know you're not, what did I just say? What did I just say?
The fundamental theory of calculus.
Guys, here's a dividing line. Here's a timeline. 1700, around 1700. Okay, fundamental theorem of calculus. Before this, ancient science. After this, modern science. 1700, ancient science.
Modern science.
Science.
Ancient science.
New science.
Other.
What's the dividing line? What's the dividing line?
1700.
1700.
Fundamental theorem of calculus in the 1700s when Newton discovered this. It changed everything. It literally changed everything. Newton didn't get knighted because of area. That's not why he got knighted. I can find the area of your carpet queen. That's not why he got knighted. He got knighted because he was able to do impossible things with it. And like I said earlier in the class, earlier, or maybe the second day, the thing that convinced people Newton was onto something, you gotta realize, I know, how many people drive? How many people drive? How many people go to places maybe they've never been before? Had to drive somewhere they've never been before. How many people use this to help them get there? How many people if I take this away and say, go to somewhere you haven't been, you guys haven't used maps. You don't even know what a map is anymore. That thing, the atlas, you know what I'm talking about? Or something you unfold. To you, that's like an abacus. You have no idea what that actually, how do you use this? This thing says, turn right. Now turn left. Now do this. There's a cop ahead. It does everything. Guys, before there were maps, people used stars to navigate. Do you know this? Do you know this? They navigated with the stars. And the royal astronomer was one of the biggest cabinet positions you could have. I am the royal astronomer. I can't even say it. The royal astronomer. It's like the Secretary of State, but more important. The royal astronomer. Newton was the royal astronomer. There was a comet that was supposed to come and it got lost. The time they were supposed to be able to see it in the sky, they couldn't see it. Newton used his calculus and made a prediction of where the comet would be in late August, a couple months later. Told them exactly where to look in the sky, exactly at what time. Told them if it wasn't cloudy, they would see that comet. They went out there, they looked in the night sky at the exact time when Newton said, and there was the comet. At that point in time, they knew Newton was on to something. I know we get so interested in our own little lives, but guys, we can land probes on comets now. We went from being able to predict where a comet would be to where we have now the ability to actually land a probe on a comet and send information back to us here. It's all started with the fundamental theorem of calculus. It all started with the fundamental theorem of calculus. But that's not where we're at right now. We're just at this little thing we're calling right-hand sums. This definition right here. We unpacked it for n equals what? We unpacked it for n equals what? 4. Now I'm going to go share a screen with you guys. Let me try to share this. I said I was gonna do that. If you just type in Riemann sum calculator, it'll take you to this screen. Can you guys see this? I know I sound like I'm in a tunnel now. How many people can see this? I can only see like 6 of you. Okay, so now I'm gonna make this function actually go above the x-axis, so I'll go to 5. Okay, so here's maybe a function. My a is -5, my b is 1.9, so maybe I'll make it go to 2. And now I'm going to use 4 rectangles, kind of like what we were doing. We're only learning about the right-hand sum, so we'll do this. Now I'm going to plot this. And so this is our approximation, guys. This is our approximation. This is kind of what we were looking at. This distance is what? The distance between here and here was what?
Delta X.
Delta X.
Delta x. This would be like my f of x sub 1. That's like my f of x sub 2. Dr. When we're bored. This is my freaking f of x sub 3. This is my f of x sub 4. And so this is my Riemann sum calculator. Now, how many people realize this is not a great approximation? If I add up that area of that rectangle plus that area of that rectangle, Dr. Warren, if you say that area of that rectangle, that area of that rectangle, and that area of that, it doesn't really approximate the area under that function down here. How many people see that? Okay, now we notice n was going to where? N was going to where?
4.
Well, it started at 4. Go back to the definition. It's the limit as n goes to where?
Infinity.
Infinity. 4 ain't near infinity. Let's make it 8. And have it do the calculation again. There's 8. Well, 8 ain't infinity. Let's try 16. There's 16. Let's try 32. If I added up these 32 rectangles where delta x has gotten smaller, but I'm still getting my f of x sub k's, are we getting to a better approximation to that area under that curve? Let's piss this thing off and do 64. And we can see that we're getting better still. I mean, I don't know if it'll do it. Let's try 128. And you can see there, is that, and now if we add all that up, is it looking a lot more like the area under the curve? If we look a lot more like it's looking, and if we went to 256, I don't know what it'll do. It'll probably say, screw you. But let's just see if it'll actually do it. Oh, there we go. Is that not looking like the area under the curve? Is that not looking at the area under the curve? And guys, that's 256. That's not infinity. That's 256. Now I can imagine Newton going, okay, and the people at Cambridge being like, Newton, yeah, okay, I get it. If you increase the number of subintervals, if you let n get bigger and bigger, yes, you're going to get something that approximates the area under the curve. But Newton, there's no way in hell you're going to let n go to, there's no way in hell you're going to let n go all the way to
Infinity.
there's no way. There's no way you can possibly let n go to infinity. And I can just imagine Newton smirking, because I think Newton was kind of an ass. I really do. I think Newton was kind of an ass. He actually had people executed. I mean, like, yeah, we learn about Sir Isaac Newton. I think there was a dark and evil side to Newton, but that's just me. That's just me. Okay. Before we use the fundamental theorem of calculus, before we do the dividing line, I need to teach you to do a couple problems to go through the misery of doing these Riemann sums. On a quest, the maximum number I will make you do is 4. In the homework, you have to do 2 and 5. Like 5, Dr. Warren, I'll never be able to do 5. Say that.
I'll never
Dr. Warren, I'll never be able to do 5.
Okay, yes you will. Yes you will. So let's unpack this for n equals 5 for n equals, I guess I'll do n equals 4. For a real function, a real A and a real B. Stand up, stand up, stand up, stand up, stand up. I can tell you need it. Brad, your butt better be in the air. Christopher, you better be up. You guys, Kelly, you better be up. Okay, now hands on the space bar, hands on the space bar, hands on the space bar, hands on the space bar. Tell everybody to wake up.
Wake up.
Say I mean it.
Wake up.
Say wake up.
Wake up.
Okay, now sit back down. My wife would be like, will you go wake up the daughters? And she thought I would go in and be like, oh, sweetie, it's time to get up for school. Which I did once. I'd be like, sweetie, it's time to get up for school. And then when they would move by the feet, boom, out of bed. Okay, and that's done. They're up. Job to the next child. Boom, out of bed. It's super easy. Wifey, out of bed. Boom. Will you wake me up? And I'm like, are you sure you want me to wake you up? Okay. So I just woke you up. So you guys are going to come up with the integral. You guys are going to come up with the integral. No, I'm not going to do that to myself. I'm going to come up with the integral. Okay, so let's just say we're looking at the integral. We're looking at the integral from 2 to 8 of x cubed dx. Now, if we were actually trying to visualize this, how many people back in high school had to work with the graph of x cubed? How many people back in high school actually had to plot x cubed? If your hands aren't in the air, I don't know what high school you went to, but you would have never passed the SOL. Okay? How many people had to plot x cubed? So plot x cubed. You said you could do it. Plot it. Plot the graph of x cubed. It doesn't have to be a perfect plot, just plot something that looks like it. Okay, so now I'm going to do it. How many people recognize it doesn't look like a parabola? How many people recognize it doesn't look like a parabola? Okay, it comes down. Like that, roughly. Now, maybe this is 2. And that's 8. Maybe that's 2 and that's 8. I'm just making it rough. Go straight up. And then shade in that area. Go straight up and shade in that area. How many people are done? How many people have actually shaded in their area? Okay. That's what this number represents. The integral from 2 to 8 of x cubed dx. Say what I just said.
Say it one more time, Dr. Warren.
The integral from 2 to 8 of x cubed dx. Say what I just said.
The integral from
2 to 8 x cubed dx.
Is the area under the function to the x-axis. Say that.
Is the area under the
Okay. How many people actually see area? How many, look at your drawing. How many people actually see physical area there? How many people see area? Is that area a rectangle? Circle, 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 circle. Triangle. Is it a triangle? There's nothing from the Greeks. There's nothing up till 1700 that can help us actually evaluate that. So we've got to think about it in terms of Newton stuff. Let's do an approximation. Let's use n equals, I'll put on earwax. 4. Okay, so you help me out. Delta x is equal to, I'll keep going.
B minus A divided by 4.
Delta x is equal to b minus a divided by 4. So you help me out. Who's in the B location? Who's in the A location? What numbers are B and A? What numbers are B and A? What numbers are B and A? I'll keep asking you.
2 and 2.
8 and 2. So this would be, in this case, 8 minus 2 over 4. Now you guys help me out. What is 8 minus 2? 6. Let's simplify 6/4. What is 6/4?
3 halves.
Yeah.
3 halves. Turn that into a decimal. Turn that into a decimal. Oh, please, please, please turn it into a decimal. Your elementary school teachers are like wondering why they're itching right now. Turn that into a decimal.
Is it 1.5?
It is 1.5. It is 1.5. Okay, now let's get our x sub k's. Now let's get our x sub k's. X0 is equal to a. Who did you say a was?
2.
2 plus 0 delta x. I've got to go from 0 all the way up to, I've got to go from 0 all the way up to 4. So x1 would be equal to a plus 1 delta x. But who is a? Who is a?
2.
And what did we find delta x to be? What did we find delta x to be?
1.5.
1.5. So it's 2 plus 1.5, which is, do the math,
3.5.
3.5. So if I was thinking about that, I'm chopping it into 4 pieces. I should have drawn a little bigger, especially on the grid. That's 3.5. That's x1. x2 is equal to a plus 2 delta x's, which is equal to 3.5 plus another 1.5. And what would you get if you did a plus 2 times 1.5? Where would you be then? Where would you be then?
5.5.
Close, close.
5.
Just 5. It's just 5. So mark this point as 5. x3 is equal to a plus 3 delta x's, which is just like moving another delta x from 5. Notice, you move a delta x from 2, you're at 3.5. Add another delta x, you're at 5. Add another delta x, and you'd be at, can you do that for me?
6.5.
6.5. And then my last one, x4 is equal to a plus 4 delta x's, which gets you all the way across the interval. So let me put in my 6.5. And then when I do this, I add another one, I'm at 8. How many people are understanding at least, if I gave you a calculator, would you be in better shape? If I gave you a calculator, would you be in better shape? Okay, now, we've got our delta x, we've got our x0, x1, x2, x3, x4. Are we done? Are we done with our Riemann sum? Are we done with our Riemann sum? Paris, are we done? Okay, the next thing we need is to write this down for n equals 4. So I take the sum of k equals 1 to 4 of f of x sub k times delta x. I know nobody's listening to me. I know nobody's listening. We're calculating this approximation for k equals 4, which is f of x sub 1 times delta x. Am I done? Am I done? Am I done? Please say no. Plus, what's the next one? Plus, what's the next one?
F of x2 delta x.
F of x2 delta x. Am I done? Am I done? Am I done? No. Plus
F of x.
x3 delta x.
still not done. N was 4. Now I'm telling you, on the quest, when I make you do this, n will be 4. So you'll be writing that down. Who did we find delta x to be? What was the value of delta x?
1.5.
So I want you to write down this same line, but wherever you see a delta x, I want you to put 1.5. Write down that same line, but wherever you see a delta x, put 1.5. It's good that I can see you because now I know it's taking longer. You're not used to writing subscripts. I'm not going to do that line. I'm not going to do that line. How many people are done? How many people are done? Okay, I think that's most. Now, underneath that line, write an equals. Who did we find x sub 1 to be? What number did we find x sub 1 to be?
3.5.
Okay, what did we find x sub 2 to be?
5.
And then so on. So what I want you to do is in the next line, your third line, I want you to replace x1 with its number, x2 with its number, x3 with its number, and x4 with its number. And keep the delta x as 1.5. And I'm going to do this one. Are you guys getting the same thing? Are you getting the same thing that I've got there? I put in a 3.5 for my x1, a 5 for my x2, a 6.5 for my x3, and a 8 for my x4. How many people are there? How many people are with me? Now who's your function? Who is the f of x? What was the function we plotted?
X.
X cubed. Now this is when you'd want a calculator. This is when you want a calculator. You're going to need to get a calculator because you're going to need to evaluate f of 3.5. So let's just do that. I'll do that one. F of 3.5. But my function is f of x equals x cubed. So this would be 3.5 cubed. And so we would grab a calculator. So somebody grab something that will multiply for us. Somebody grab a calculator and do 3.5 raised to the third. And tell me what you get. 3.5 raised to the third.
42.875.
42.875. And then we're going to multiply that times 1.5. I'll do the next one. The next one, I need f of 5, which is 5 cubed. That one I know. 5 times 5 is? Times 5 more is? You got 5 quarters. 125. So this would be 125 times delta x. Plus, let's do this one. I need your help. What is 6.5 cubed? Find 6.5 cubed and help this old man.
274.625.
274.625. Thanks, Jay. Times 1.5. And I'm not sure I can do 8 cubed. Tell me what 8 cubed is, guys. Tell me what 8 cubed is.
512.
512, I should be able to do that. Times 1.5. Now, am I done yet? Am I done yet? Am I done? Now what do I need to do? Now what do I need to do?
Multiply by delta x.
Do that one. do that one, do that one, do that one, and then you gotta do with what with all those numbers?
Add 'em up.
Add them up. Guess who's not gonna do that? Guess who's not gonna do that? Guess who's not going to do that? No, yes, you're not going to do it either. Remember, I took away your what on your test? I took away a what?
Calculator.
Now, how many people are happy I took away your calculator? How many people are like, oh, Dr. Warren, that's nice, then I won't need a calculator. That means I gotta pick a problem where you don't need a calculator. Now, in the homework, guess what the book wants you to use?
Calculator.
A calculator. Okay, so let's go back and make our software do this. And then we're gonna end class. Let's go back and make our software do this. We're gonna go back and share our screen. Okay, can you guys see the screen yet? Is that live for you guys? Miles, can you see that? So what was my function? It wasn't 5 plus x to the 4th minus 3x squared. What was it?
X cubed.
X cubed. Okay, what was my A?
2,
2.
What was my B?
8,
8.
8. And how many subintervals were we using?
4,
4. Okay, we want the right hand, so you just drop down and do right hand. So let's let it plot it. Okay, so there we go. This is what it would look like. Notice how tall this is, 512. Is that what we found? 512. Our delta x is 1.5. Now look at that right there. The actual area under the curve they're saying is 1020. And what was our approximation adding up those 4 rectangles that we didn't do? Can you read that?
1,431.75.
Now guys, would it be hard to change this to an 8 and do it by hand? Would it be hard to change this to an 8 and do it by hand?
Yes.
Yes, but notice how simple it is for this to do it. And now we're still not much better. Let's go to 200. Imagine doing this by hand. You're like, Dr. Warren, there's not a chance in hell I'd do this by hand. Okay, so now we look, even with 200 subintervals, graphically does it look like the area under the curve? Graphically does it look pretty good? But look, NASA's not going to use this. The actual area is 1020. We don't even have all the decimals right. We have 1027. Let's do 500. It's not going to want it, but we'll see. Ooh, look at that. It does, in fact, look like the area under the curve, but we're still not close. It's 1023. Okay. I assigned, I think, 3 homework problems. Asking you to do stuff just like this. How many people think they can do this for n equals 2 and n equals 5? That's what I asked you to do. Now here, let's go to Cambridge. I'm going to end class with this. Let's go to Cambridge. Imagine being a professor and Newton saying, okay, find that area. And they're like, Newton, you're out of your flipping mind. I'm not even going to do it for n equals 4. I don't have a calculator at 1700. I'm not going to even do it for n equals 4, buddy, let alone n equals infinity. On Wednesday, we're going to do it for n equals infinity. For Wednesday, we're going to do it for n equals infinity. And it's called the fundamental theorem. Calculus. Thanks for playing, guys. Thanks for being back. I miss you being in my classroom. I miss you. Miles, I miss you sitting over there. Paris, I miss you sitting here. Mason, miss you back there. Miss you guys. I will see you on, when's your quest?
Friday.
All right, I'll see you on Wednesday, virtually.
Dr. Warren.
See you guys.
Thank you.
Thank you.